All right. So for those of you just joining us, we were working on warm up number 17, and it reads as follows for number one, part A and B. It reads simplify to lowest terms, but in parentheses it says factor each number first and then simplify. So for part A, it's 24 over 60. Part B is 5t cubed over 10t squared plus 15t. For numbers 2 and 3, it says factor. And number 2 reads as follows, x squared plus x minus 12. And number 3 is x cubed plus 8x squared plus 3x plus 24. For number 4, it says solve for y and evaluate when the domain is -1, 0, 1. Number 4 reads -12x minus 3y equals -9. And for number 5, it says add or subtract, and they give us 8 12s plus 5 18s. All right, show me with fingers how many more minutes do you need for the warm-up? I see 1 minute, 2 minutes, 0 minute. Let's go. All right, 2 minutes from this point. Go. All right, so there are the answers for numbers 1, A and B, 2, 3, and 4. Make sure you check your notes. I'm going to go over number 5 just to make sure we're on the same page in regards to the process that we're looking at, because we're going to get there pretty soon. All right, here we go. Number 5, 8 12s plus 5 18s. 8 12s. 8 12s, my goodness, plus 5 18s. Okay, hold on. This is doing something kind of weird. Okay, let me try it again. 8 12s, okay, plus 5 18s. All right. So first, let's factor the denominator in prime factors for both. I'm going to bring down the numerators, 8 and 5. Prime factors of 12 are 2 times 2 times 3. Prime factors of 18 are 2 times 3 times 3. All right. So what do they have in common? So let's see. In common, they have a 2 and a 3. 2 and a 3. All right. So for this first one, what does the second one have extra that the first one needs? Yeah, the 3. So I'm going to multiply times 3, and I'm going to multiply times 3. Numerator, denominator. Look at the denominators now. What does this one need that this one have or has? The extra 2. That is correct. So I need to multiply this one times 2. Times 2. Numerator and denominator. And now we can rewrite our fractions. 3 times 8, or 8 times 3, that's 24. 2 times 2, 4. 3 times 3, 9. 4 times 9 is 36. Plus 2 times 5 is 10. And this is going to be the same denominator, 36. So now we can write it as one fraction, 36. Focus on the numerators. 24 plus 10, that's 34. I'll leave it like that for right now. I just wanted to go through the process. You can simplify if you want. But the process is what we're going to get to pretty soon. Okay? All right. Let's move on. So your agenda for today is warm-up number 17. We're simplifying rational expressions. And we are, our home play is play sheet practice. Practice A 10.3 all only. Play sheet practice A 10.3 all only. Okay. So our asynchronous code is VBLIE. 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 Once again, when you log in, make sure you put the number first of the period that you're in, your first and your last name. All right, your previous home play was page 331. Some of you already went to Canvas to turn that in. Some of you go right now if you haven't. However, one thing that you're going to notice now when you go to your modules, if you notice way at the bottom, I included a new module, which we're starting today, which is rational expressions. Did anybody notice that? Yeah. And in there, I included the play sheet for today. Your play sheet should be in there in PDF format. Okay. All right. So now that we turned that in, once again, your home play for tonight is the play sheet practice A 10.3 all only. Okay. All right, let's move on. Our objective for today, I can simplify rational expressions. Once again, I can simplify rational expressions. And if you notice the main topic at the top, which we'll get to pretty soon, is rational functions and rational equations included with rational expressions. But today we're only going to focus on rational expressions. All right, so I can simplify rational expressions. What's our main concept once again, Zach?
Rational expressions.
Thank you. Yes, and we're simplifying today. So here we go. Freyer model, rational expressions. What are they? Rational expressions are expressions or algebraic expressions where the numerator and denominator are polynomials. Let me repeat that again. Algebraic expressions whose numerator and denominator are polynomials. What are rational expressions? Algebraic expressions whose numerator and denominator are polynomials. Examples: 6 over g plus 4, 2x plus 1 over x squared minus 15x, and 2x plus 6 over x squared plus 5x plus 6. So these should look familiar to some of you. However, what is the most obvious thing that you notice on those examples, guys? What would you tell someone that they are, even if they didn't understand polynomials? What are they? Other than rational expressions, what would you call them? Alvaro?
Fractions.
Fractions. Yeah, that is correct. Because we have a fraction bar there, and fraction bar there. All right, non-examples. 6 over g plus 4 equals to 2, and negative 3 plus x equals to 10. So the first thing that we made an observation is that all of these examples are fractions, otherwise known as rational expressions. Okay. But according to the definition, now that we're focusing on rational expressions, they are algebraic expressions whose numerator and denominator are polynomials. Let's see. Look at this first example. Is the 6 a polynomial? Yes. It's known as a one term, which is a monomial. Okay, look at the denominator. How many terms does this one have? 2. It's a binomial. But all of them together are known as what? Polynomials, yes. Look at this next one. 2x plus 1 is a binomial. This one is x squared minus 15x is also a binomial, but both of them together are known as what? Polynomials. Okay. Let's see. 2x plus 6, binomial. X squared plus 5x plus 6, trinomial, but together they're what? Polynomials. Yeah, okay. Now, what's the other term? Algebraic expression. So basically is that it's an expression that has a variable. Now, the first example that I gave you, the 6 doesn't have a variable, but for the purpose of just showing you the different looks, I included that one in there for the sake of that. Okay, look at the non-examples. Why are these not rational expressions? Let's see. John, why is the first one not a rational expression?
Because they're equal to something?
Yeah, both of them are equal to something. So they are what? Equations. And what are we looking at today? Only what, everyone? Yes.
Expressions.
Thank you. So go ahead and write me some hashtags. Hashtag what? Hashtag what? Hashtag what? What makes a rational expression a rational expression? All right. So hopefully you wrote something in regards to hashtag what, Enrique?
Hashtag fraction.
Fraction. Very good. Elizabeth, hashtag what?
Hashtag no equal sign.
No equal sign. Thank you. One more, Emily P. Hashtag what?
Expressions only.
Expressions only. Okay. And I'll give you one more hashtag. Polynomials. They're not gonna leave anymore. Woo! All right, we good? Yes, Mr. Q. All right, let's move on. All right. Now, here's some flashback for some of you that were with me. Who remembers that one? Let's go. Let's go. I remember back in when you guys were in 8th grade that I introduced fractions using this definition. Some of you were freaking out. I was like, what does that mean, Mr. Q? Well, here it goes again. Q stands for what? Quotient, which means it's a result of a division. That's why we use the letter Q. So this is the definition for quotients or for rationals. Here it goes. Quotients are the set of all m over n. What does m over n look like? Fraction. So let me read it again. Quotients are the set of all fractions where m is over n. Okay. What else? M is an integer and n is an integer. Do we know what those integers look like? Yes. But here goes the most important thing. Look at this one. N does not equal to 0. Once again, look at it. Where's n? In the denominator. So what does that mean? The denominator cannot equal to 0. Let me repeat that again. The denominator cannot equal to 0. Why not, Mr. Q? Well, if you remember when we did slopes or whatever, the 0 at the bottom was an undefined slope. So therefore, we cannot have 0 on the denominator. Today, when we simplify rational expressions, we are going to find that we have expressions on the denominator, and we're going to find what we call excluded values. What are excluded values? Any number that makes the denominator 0. So in this case, since I only have the variable n right here on the denominator, what would be my excluded value? 0. But what if I had something else like n plus 1? Then we needed to find the number that would make that equal to 0. Does that make sense? Yes, Mr. Q. All right. So we're going to do an activity, see if we get there. But before that, I'm going to give you some steps so that you don't get lost with what we're doing today, because we're going to be doing a couple of things. All right. Here we go. Steps. Write these down. Step 1, identify the excluded values. In parentheses, what are they? Write the denominator equal to 0 and solve. That's how we get the excluded value. Step 2, factor completely. Do we know how to do that? Yes. The numerator and denominator. Step 3, simplify after identifying the giant ones. Copy that. I'll give you 2 minutes. Dos minutos. Go. All right, you should have already copied those. Once again, number 1, identify the excluded values, which says write the denominator equal to 0 and solve. Step 2, factor completely the numerator and denominator, which is the GCF. And step 3, simplify, which is after identifying giant ones. All right, copy this one. Example 1. Example 1 reads, identify the excluded values, then simplify to lowest terms. The rational expression given is 2x over 2x plus 6. And I left the steps on the right side just so that we can have them as reference. Copy that, please, and I'll go over the steps. 20 seconds. Okay. Once again, example 1 says identify the excluded value, then simplify to lowest terms. So writing utensils down, look up to the screen. There's two different things that the problem asks us to do. The first thing is to identify excluded values. And the second thing, to simplify. I wrote all 3 steps together so that you know what to do with these 2 things, but there's 2 different tasks here. So what's the first task? I'm gonna do that in blue, which is step 1, which is identify the excluded value. So write your utensils down, eyes on the screen. I'm gonna go over this really quick. The first task, identify the excluded value. I'm gonna write it down here, excluded value. I'm gonna label that EV. Some of you are like, oh, I think I'm having flashback, Mr. Q. Yes, here we go. So the excluded value, we write the denominator, which is 2x plus 6. However, what did we say that denominator couldn't be? 0, which means we need to find a variable or a value for the variable that makes that 0 because we're gonna exclude it from not using it. So we need to set this equal to 0. Now that I have it equal to 0, now I can solve for x and find that number. So what do? Minus 6, bring down the 2x equals to -6, divide by 2, divide by 2. Therefore, x equals -3. So guess what? My excluded value is -3. Copy that, please. All right. Now, what does that mean, Mr. Q? The excluded value. Okay, guys, so the reason that we want you guys to identify the excluded value is because eventually when we get to rational functions or equations and we graph this, we cannot use a value that makes the denominator 0. Let me explain. What was the excluded value? -3. So that means if I was to substitute -3 here, that gives me -6 plus 6, which is 0. Can we have 0 as a denominator? No, because it's undefined on the graph. So when you graph, we can't use that value. Does that make sense? So on the domain, when I would ask you to graph it, which is the only value that you're not going to use on the x values or the domain? -3, because the graph will not graph at that point. Okay? So you don't have to copy this. I'm just going to erase that. I just did that to explain the why we don't use that value. Okay. So the first part is done. We identified the excluded value. What do we do next, Mr. Q? We're going to simplify. We're going to simplify. That's the last thing that they want us to do. And I wrote the 2 steps that you need to do. So here we go. I'm going to do the first step to simplify in green. Writing utensils down, you're just paying attention. It says, factor completely the numerator and denominator. All right, so let's see. Is this factored completely? The number, yeah, it's a prime number times x, okay. How about this one? Is this factored completely? No, what's the GCF? 2, and we're left with x plus 3. Step 2 of our entire process today is done, but for simplifying, that step is done. Now I go to the last step, which is what? Simplify. How do I simplify? Identify the giant ones and write it out. Let's see, what's my giant one here? The 2, and what do we have left? X over x plus 3, and that's simplified. Simplified. Copy that, please. All right, just to recap, they ask us to do 2 different things here. The first one is to identify the excluded values, and number 2, to simplify the expression. So how do we find the excluded value? I wrote it here. Step 1 is to take the denominator and put it equal to 0 and solve. Did I do that? Let's see. denominator equal to 0, and solve. Yes, the excluded value is -3. I'm done with that part. What do we do next? We're going to simplify the expression. How do we do that? Factor completely the numerator and denominator. Did we do that here? Yes. And the last step to simplify, identify the giant ones. Here's my giant 1. What is 1 times whatever's left? Well, whatever's left. There it is. Show me with your fingers how good you are with these so far. Okay, yeah. All right, let's continue. Example 1Q, copy this. 6x over 3x plus 9. All right, now that you did one with me, let's see how you do with this one by yourself. I'll give you some time. Ready? Go. Once again, 2 things you need to do. Identify the excluded values and then simplify. Go. All right, let's see how we did. First things first, they want us to identify the excluded value. So I'm going to write over here just EV for short. You should have taken the denominator, 3x plus 9, and equal that to 0. From there, solve. Let's do -9 minus 9. 3x equals -9. Divide by 3, divide by 3. X equals -3. My excluded value is -3. Hands, have you got that? Okay, good. Now, what does that mean? That we cannot use that for our X values once we get started with graphing, okay? All right, so I'm done with step 1. What else do they ask us to do? They want us to simplify to lowest terms. So the first thing I need to do is what? Factor completely. How do we factor 6x completely? 2 times 3 times x. Okay. How about this one? What's GCF for the binomial? 3, and we're left with x plus 3. All right, and lastly, I need to identify giant ones to simplify. Do you guys see a giant 1? Yes, the 3 over the 3, right here. What do we have left? The 2 and the x, so my numerator is 2x. My denominator is x plus 3, and I'm done. Hands, have you got that? Okay, good. Now, one thing that I do get from time to time, a mistake that some of you make, look up to the screen, write your utensils down. Here it goes. Some of you got this, and then you wrote x plus 3, which is fine without parentheses. But here goes a common mistake. Don't do this. Look up to the screen. Some of you do that. This is incorrect. Why, Mr. Q? Because look at the numerator. The numerator is 2 times x. What is here in between them? Multiplication. Okay. Look at the denominator, x plus 3. What's in between them? Addition. When we have addition or subtraction, we cannot identify giant ones. Does that make sense? Yes, Mr. Q. That's why we leave it like this. All right. All right. So show me with your hands how comfortable you are, 1 being the lowest, 5 being the highest with these. Okay, let's crank it up about 4 notches. Yeah? Here we go. Example 1 super Q. Copy this. Example 1 super Q reads x squared over x squared minus 5x. Just copy it. Don't do anything else. I'm going to go over this one because this is a little bit different. All right. Here it goes. I'm going to write EV for excluded value. Write your utensils down, look up to the screen, or you're going to miss it. This is one of those that it has a lot of stuff that you should know or you should remember, but here it goes. We have x squared minus 5x, because they tell me to write the denominator and equal it to 0. All right, but right now it looks kind of weird. So how can I solve this, Mr. Q? Well, let's factor this first. How can we factor x squared minus 5x? What is GCF? X, and we're left with x minus 5. So if this is this, and the rule is that we equal it to what? To 0. So that means we have x equal to 0, and what else? X minus 5 equal to 0. So what's my first excluded value? The first excluded value, Mr. Q, is 0. But now, since we're dealing with squares, now we have a new excluded value. Plus 5, x equals 5. This is my second excluded value. Copy that, please. All right. So we're done with excluded value. What else do they ask us to do? Simplify. All right, so here goes the next step. How can we factor this one completely, the numerator? X squared is what? X times x. Okay. How about the denominator? What was GCF we said? X times x minus 5. All right. Do you guys see the giant 1? Yes, right here. So we're left with x over x minus 5. And we're done. All right. So I showed you the only different step that we do on this one was the excluded value, that this has 2 excluded values because now we're dealing with what? Quadratics on the denominator. I'm going to give you one, see how you do by yourself with one of these. It looks very similar. Here it goes. Example 1 mega Q reads 2x over x squared plus 7x. Find me the excluded value and then simplify. I'll give you 2 minutes. Go. All right, let's see what we got. First things first, excluded value. And I got x squared plus 7x and all that equal to 0. Continue from there, please. Avery, what do I write?
You write x, parentheses, not parentheses.
Parentheses.
Yeah, x plus 7.
All right. Continue from there, Malachi. So this step, if you want to call it something, this is called factoring, right? We factor that. So what do I write, Malachi?
Yeah, so x equals 0, and x plus 5 equals 0 too.
X plus 7.
Oh, yeah.
0. So then we solve. 7 minus 7, x equals -7. So my excluded values are 2 here, which is 0 and -7. Hands, have you got that? Okay, good. All right, let me go to simplifying. Factor completely, 2 times x. Factor here is x. We got x plus 7. The giant 1 is right there, right here. So therefore, we're left with 2 over x plus 7. Hands, have you got that? All right, good. Show me which ones you are with these so far. Yeah, okay. 5, 5, 5, 4.5, yeah. All right, let's crank it up 2 more notches, yeah? Yeah. Copy this one. 6x squared minus 6x over 3x minus 3. Example 1, super duper Q. Once again, we're still doing excluded value and simplifying to lowest terms. Now this one, since we already did a couple of practices, you should be able to do this one completely. I'll give you a head start. A couple of minutes. Ready? Go. All right. See what we got. Excluded values or value. Let's see. We have the denominator, which is 3x minus 3. We set that equal to 0. If you notice, it's not a quadratic, so that means we're only going to get one excluded value. So let's see. Plus 3 plus 3. 3x equals 3. Divide by 3, divide by 3. X equals 1. So my excluded value is 1. Hands if you got that. Okay, good. So let's simplify. First step is to simplify or to factor completely. So let's look at this numerator. Now we have a binomial. Is there a GCF first? Yes. What is it? 6x. And we're left with x minus 1. Okay. However, is this completely factored? No. How can we factor the 6? What does that become? Yeah. 2 times 3 times x. So this became this. So let me write it over here so that you can see it. 2 times 3 times x minus 1. All right, let's do this one. What is GCF for the denominator? 3, and we're left with x minus 1. All right, so since it's completely factored, I'm going to bring it over here. 3x minus 1. Okay, there it is. All right, so let's simplify it. Giant ones. Oh, the 3's. Here it is. What else? The x minus 1. X minus 1 are also. So what do we have left? The 2 and the x on the numerator. How about on the denominator? What do we have left on the denominator? Nothing, but we can't do nothing because it's 1 times 1. What is 1 times 1? 1. So we end up with 2x over 1, or in other words, 2x. Hands if you got that. Let's go. Let's go. Some of you are like, I kind of got stuck, Mr. Q. All right. All right, let's do another one. I think we got the excluded value down. Let me give you a different view. See if, here goes another one. 8x squared plus 16x over 2x minus 2. Once again, this one's very similar to the one we just did. You should be able to do this one completely now if you made a mistake on the previous one. I'll give you a minute. Go. All right, here it goes. Excluded value. 2x minus 2 equal to 0. Plus 2 plus 2. 2x equals 2, divide by 2. X equals 1. My excluded value is 1. Factor. GCF here is what? 2x? No, 4x, my bad. 4x. And what do we have left? 2x plus 1. Is that correct?
Mr. Q, isn't it 8x?
8x. Yeah, my bad. I haven't had my coffee. All right. 8x. Thank you. And we're left with x plus 2 over. However, 8x could be factored more, can it? Yeah. 2 times 2 times 2 times x. Let me make some space here. Then we got x plus 2 over, GCF here is 2, and we're left with x minus 2. All right, identify giant ones. What's my giant one?
Isn't it 1?
Oh, 1,
X
sorry.
minus 1.
Yeah, sorry. Thank you. So 1 here. X minus 1, okay? All right, so let's see what we got. What's in the numerator? 2 times 2 times x, that's 4x. And we got x plus 2. What's in the denominator? X minus 1. And we're done, since we can't simplify anymore. Show me if you're talk up DR with ease. Yeah, we got this, okay? Now the last kind is this next one, and this is where I'm gonna stop. X squared minus 4 over x squared plus 3x plus 2. Example 1, Star Wars Q. So here goes, as you copy it, I'm gonna go over this example because we're running out of time. Here it goes. Excluded value. The denominator is x squared plus 3x plus 2, and all that equal to 0. You're like, Mr. Q, okay, so this one's a little bit different, I know. But what did we do when we had a binomial? We had to factor out the GCF, is that correct? This one doesn't have a GCF, but can we factor this expression right here? Look up, guys. Can we factor this? Yeah, what do we use? What goes on top? 2. What goes on the bottom? 3. Factors of 2 that add up to 3. 1 times 2 and 1 plus 2. Okay, so therefore this is x squared, sorry. And then instead of 3x, we write what? 1x plus 2x, and then we bring down the plus 2. Factor by grouping, these two, x plus 1. GCF here is 2, x plus 1. So my factors are x plus 1, and the other one is what? X plus 2. Now check this out. Now that we have our factors, we set them equal to what? To 0. And we solve. So minus 1, x equals -1, minus 2, x equals -2. So my excluded values are -1 and -2. All right. And just to go to the next step, look at this one. Your patterns. What are the factors for x squared minus 4? Who remembers? No? Paul, do you remember? X squared minus 4, what does that factor to? For those of you that forgot, square root of this, square root of this. It's a difference of squares. All right. Factors of this, we already have them down here, which is what? X plus 1 and x plus 2. We already did the work down here. And then identify giant 1. So what do we have left? We have this one on the numerator, this one denominator, so we end up with x minus 2 over x plus 1. We'll stop right there. The play sheet is basically all we did today, so make sure you go to Canvas to get the play sheet. It's on that module that I included in there, and you have your asynchronous code. Have a good one, guys. Enjoy your day. I know we went a little longer, but we got through the session. Have a good one. Good seeing you guys. Peace. Bye.
Bye, Mr. Q.
Bye.